Hello friends. A pilot cannot fly a plane without knowing all the knobs in its cockpit. Similarly, you cannot do an ultrasound without knowing all the knobs in your ultrasound machine. So today, let's learn everything basics knobology of the ultrasound machine. So this is Philips Epic 7 machine, which is a very nice machine for a pediatric and neonatal use. And as you can see, we have all the possible probes needed for the ultrasound or the echo. So we have this S12-4 probe, which is a probe for a scanning or echo for a newborn or an infant. And then we have S83, S51. All these are the sectoral probes for different ages. And as we learned, we can use different frequency, smaller frequency probe for bigger babies so that the penetration is bigger. We also have the curvilinear probe. Two types of curvilinear probes are there. And also important to note is there are ECG leads. So every machine should have a ECG leads which needs to be corrected to a baby so that you can time the cardiac cycles, and then you can take the number of cycles and interpretation also of the various loops related to the cardiac cycle. So now let's look at typical knobs which are present in any ultrasound machine. Generally, most of the machines will have some sets of buttons. There will be a rolling ball and there will be few more functions around it. Now when you're scanning, you start always with for any scan or ultrasound you start doing 2D first. So 2D or the B mode will be done by the 2D function. Then you put the color on, which will tell you the direction of the flow. And then if you want to measure the velocity of that flow, you put either pulse wave Doppler PW or continuous wave Doppler CW. So generally many machines will have a gain function. In this particular machine, the gain function is actually fixed on this 2D or decrease the gain as on the same knob. As you can see, this is very bright and then decreasing it's very dark. Then the next button is the depth button. So depth button basically adjusts the depth on the screen. As you can see here, you can adjust that. This is the depth is increased and this is depth is decreased. So as you can see, as you change the depth, the organ will appear more closer to the screen, so it will look larger basically. So next button is the focus button. Focus is basically on the screen. Whenever you have your area of interest or the organ of interest, you just adjust the focus button. So now you see this line which is moving, it's not only changing its width but also changing the focus. So as you can see, it will change and your focus will change. And as we learned in the physics class, the area where the focus is will appear much more brighter and clearer. There is also zoom button. Now zoom button is basically on the screen when you want to focus any particular area or a box of the screen, suppose aortic valve or pulmonary valve, you basically zoom out that area. So as you can see, it is zooming out that particular section to a significant proportion. So we saw that the gain button is fixed actually on this machine on a 2D knob only, but there are also few additional knobs are there, and these are called as TGC or sectoral gain. So basically you can adjust the gain of each and every sector on the screen based on these knobs. So as you can see here on the screen, now the gain is very less. Now I start moving the knobs. Top two knobs, it will increase the gain and the top triangle. Then next two knobs will increase the gain here. The next two knobs will increase here, and then next two will be here. So as you can see now, all the knobs have come from on the completely on the right side. They were here in the middle, and I just moved them completely on the right side one by one, and you can see the change on the screen. It's completely bright now, which was originally little darker as in this screen when they were in the middle section. So basically you can adjust, suppose you want to just zoom out the middle portion, you can zoom or increase the gain on the middle portion like this. So this is also again selectively highlighting certain portions of the organ while you are scanning. So now this machine has got this knob which actually corresponds to the sector width. So all the knobs are corresponding to whatever the function written here. So like this is M mode, this is some another adjustments are there, but basically you can adjust the sector width here on this knob and see what happens on the screen. So now I'm changing the sector width, so see it's increased, it's wider sector width, and now this is very small sector width. And we learned that how the temporal resolution changes when you change your sector width. You get better quality or clarity of the image when you have a narrow sector width as against a wider sector width. As all of you might have appreciating this line here which is moving in the middle of that sector, that's the line which has got this one big dot and there are multiple smaller dot. So this dot is like the sample gate where you want to measure the pulse wave or continuous wave Doppler. So you can move this line and this dot with this ball. So this ball controls up and down, side to side movement will be done by this ball like this. So you can see here how the line is moving, side to side movement, and see the big dot is moving from top to bottom. So I can adjust and place this big dot anywhere in the desired location, especially like when we do it pulse wave Doppler or continuous wave Doppler, we just put this big dot in the middle of the valves like aortic valve, pulmonary valves or AV valves. Now we are focusing on this screen, which is also could be part of the Knobology, the knobs on the main screen or the main machine, or in many machines nowadays some of the functions are displayed on the middle screen or even on the part of the main screen. So here as you can see, it starts with patient. So you have a patient. When you click patient, it basically displays patient information and you have to enter all the names and everything in this machine, and this is important so that you can retrieve this in this study later on whenever you require. Then comes then there are, once you have done that, so you can see here I'm just writing ABC whatever XYZ, surname is there, and then you can write the first name, and then you can write the patient ID, medical record number, and you need to spend that time because you can retrieve this just based on the patient information. And then you can write even who's performing the study, and then you can proceed to the protocol, and that will start the scan. Then there will be an option of probe selection. So many times many machines will have a probe button where multiple probes will be displayed inside, or like here already X7, S8, S12, S5, all the probes are basically connected and you can select any of the probe which is connected. Then you have other buttons here, like on the top here there is a review button, which means that whatever scans you are doing in between, if you want to review, you can click that and all the images will be displayed. At the end of the scan, you can click the report button and that will also give you summarizes, or it will pull all the numbers or calculations you have done, and it might even create a report in a good machines that can be even preset. Then you have a keyboard which will allow you to type and annotate any structures you want to write, like LVO, RVO, or any valves you want to write. or in the head scan you can write right side, left side, etc. can be done on the keyboard. Now there is an up and down button which is important for you to change the orientation of the probe on the screen, like something called as inverting. So as you can see on the screen, when I select up and down button, the probe comes here. If I turn it again, it goes up. So this is the P is the mark where the probe marker is there. So P marks for the marker of the probe, or there is a knob light or of the probe which is there in all the probes, that will be marked on this screen. And when you are viewing from the top, you will see the sector going downwards like this. And if you want to look from bottom, you just do up and down, and it will be displayed like this, up and down, and the probe will be on this side. Now if you want to change it on other side, you can do that way also. So you can do right to left, left to right, and that we will tell you in different views which we will be going through. Now there is, when you want to acquire or save the images, you can select capture type. Prospective, that means whatever you are scanning, you will be prospectively storing, and retrospectively means whatever you have scanned, the previous part will be stored. So you can change that prospective versus retrospective. Then you can select the ECG connected to ECG1, ECG2 or third lead. Generally we keep it for ECG 2 leads. And then also you can decide how much length of the video you want to store, which you can decide based on either the number of bits, that means your ECG has to be connected, so you can do 3-4 bits, or length of the loop, which is like 1 second, 2 seconds, 3 seconds, so you can do like 2 to 3 seconds. So you can select how long the clip you want to store. There are these functions like harmonics. There are these additional machines functions which are very specific to this machine, and you need to understand these buttons with help of your application specialist of the company. So harmonics, I think we discussed. Harmonics will add some additional clarity to the image. And then there are this compression, 2D image optimization, etc., which can be help you to adjust that. Then once you have optimized your images and gain, etc., you need to acquire the images. For that you have an acquire button or save button or store button. Various machines will have different names, so it will called acquire. There is an iScan button which actually automatically adjusts the gain, or it changes the brightness and gain, which will make your image very optimized. And then there is a freeze button. So whenever you want to do the measurements, you have to freeze the image and then acquire. So generally all the videos are acquired directly. So while you are scanning, you hit acquire, it will save the video. And if you want to do measurements, you freeze, do the measurements, and then acquire. With this ABC, basically you can annotate them, so you can put whatever notes you want to put, right side, left side, SVC, etc. And if there is an issue, you can do erase. There is a pointer button which actually brings the pointer and select the pointer, which you can move it on the screen. And then this is the main ball of the most of the machines, which controls your pointer. It controls your pointer, and it controls your pulse sample gate, etc. The cursor, which you can move. So ball has got a lot of function. It's multi-purpose, and again you need to get used to it, what all it can do. Now next, last but not the least important function is the measure button. So when you hit measure, the measure should have all the measurements recorded. So when you hit this, basically it opens up a lot of dimensions, measurements on the side here, as you can see. And basically you can select whatever parameters you are recording, and then do the measurements, and the machine will save in that particular format. Basically you can measure anything, so you have to select the ball function and the left click, and you can do a measurement, and this will get displayed. here, like the distance, and then you can assign it to a particular measurements on the left side. Now some parts of the screen which you want to show. So this is the sector and this is in 2D, and you can see there are some numbers are there written there, this means that what probe you are using, and this is the hertz, which is your frame rate which you are using. And last time we said that you see how this frame rate changes when I reduce the sector width. See how the frame rate goes up. It went up to 166 from 187. Similarly, if I change the depth, see how the frame rate is going to 171. So changing the depth and sector width, this frame rate will change. Then I am putting color box. So that's the color box now. When I put the color box, this displays the color scale on the right side. So this is 61 to 61 plus to minus. The red is always on the top, blue is on the bottom, and you can adjust the scale with a scale button which is there on the screen. See, this scale can be lowered. As you can see, the number is changing. So this is a very 15, 23, 30, 44, and so on and so forth. So there is a scale button which actually controls the scale. So as we discussed, the scale ranges from 15 for the coronaries, then maybe 35 to 45 for the pulmonary veins, SVC, IVC. Then generally 60 to 70 is good enough for AV valves and most of the structures in the heart. And when you want to measure the pulse width Doppler at pulmonary artery or aorta, then probably 90 to 100 is good, and then higher scale probably for the regurgitant lesions. But you won't get that high scale in color Doppler and pulse width Doppler. You need continuous wave Doppler to capture the images which are more than 200 centimeter per second. Otherwise, the color Doppler and the pulse width Doppler has got a acoustic limit beyond which it cannot be increased. So after color, you hit pulse width Doppler, and then so this is the pulse width Doppler we selected. You get something called as baseline and also scale of the pulse width Doppler. So if I move scale, look at what's happening here. So this is pulse width Doppler. There is a scale 0 to 120. Now I can increase the scale up to 160, up to 200 or 300. So that scale can go up. But on pulse width Doppler, it will not capture more than 200. But on continuous wave Doppler, it can capture easily up to 300, 400. As you can see, now I have changed CW. It has gone up to 4 meters, 6 meters per second. So it can really go up significantly under continuous wave Doppler. Then this orange line is the baseline, which you can adjust up and down depending on which direction in Doppler you are capturing. So the blue jets will be below the line and the red jet will be above the line. So you need to adjust the baseline accordingly. So that brings ends to the session on knobology. Again, this is specific for the Philips machine. You need to know your machine, whatever brand you are using, all the knobs and all the buttons, and the best person to learn from that is the company person or the application specialist. So whenever you buy a machine, or if you already have a machine, call them and then ask them to show all the knobs and then play with them so that you understand the machine well. So good luck with the scanning.